Cutting in a J-block is the preferred method for mounting outdoor electrical fixtures. J-blocks provide a weather-resistant barrier between the siding and the electrical fixture. They prevent water from seeping behind the siding and causing damage. Cutting in a J-block is the most professional and recommended way to support outdoor fixtures. While it may be tempting to use a pan box or pop-in box, it is not the ideal solution. Firstly, pan boxes and pop-in boxes are not designed to withstand direct exposure to water. Secondly, screw gaps in these boxes can allow water to penetrate the siding, leading to rot and damage. Thirdly, these boxes are typically designed for indoor applications and are not suitable for exterior use. In very rare cases, it may not be possible to cut in a J-block due to structural limitations or other obstacles. In such cases, consider the following alternatives. 1. Apply a generous bead of silicone sealant around the base of the fixture where it meets the siding. This will help prevent water penetration. 2. Some outdoor fixtures come with weatherproof gaskets that can be installed between the fixture and the siding. 3. If possible, mount the fixture directly to a stud behind the siding. This will provide additional support and prevent the fixture from moving or becoming loose. Encourage communication with the siders about the missing J-blocks. Explain the importance of weatherproofing and the potential risks associated with not having them installed. If the siders refuse to install J-blocks, consider hiring a qualified electrician to assess the situation and find a suitable solution. The primary concern with using a pan box or pop-in box directly against the siding is the lack of a proper weather seal. These boxes are typically designed for indoor use where they are not exposed to rain, snow, and other elements. The design of these boxes doesn't account for the uneven surface of siding, and gaps can easily form between the box and the siding. These gaps allow water to penetrate behind the siding, which can lead to several problems including wood rot, mold growth and damage to the building structure. In colder climates, water that penetrates the siding can freeze and expand, causing further damage to the siding and the underlying structure. The expansion and contraction of the siding due to temperature changes can also exacerbate the issue by creating larger gaps and causing the fixture to become loose over time. Furthermore, pan boxes and pop-in boxes are often made of materials that are not designed for outdoor use. These materials can degrade over time when exposed to sunlight and moisture, which can compromise the integrity of the installation. J-blocks, on the other hand, are specifically designed for this purpose. They are made of durable, weather-resistant materials and have a built-in flange that creates a tight seal against the siding. The flange prevents water from penetrating behind the siding and protects the electrical connections from the elements. When installing a J-block, it is important to ensure that it is properly sealed to the siding. This can be done by applying a bead of caulk around the perimeter of the J-block where it meets the siding. The caulk should be specifically designed for outdoor use and should be compatible with the siding material. In addition to providing a weather seal, J-blocks also provide a solid mounting surface for the electrical fixture. This helps to prevent the fixture from moving or becoming loose over time, which can damage the siding and create a safety hazard. When mounting the fixture to the J-block, it is important to use screws that are the correct length and diameter. The screws should be long enough to penetrate the J-block and the underlying structure, but not so long that they protrude through the siding. If it is not possible to install a J-block, there are a few alternative methods that can be used to support the outdoor fixture. One option is to use a weatherproof box with a built-in flange. These boxes are similar to J-blocks in that they provide a weather-resistant seal against the siding. However, they may not be as durable as J-blocks and may not provide as much support for the fixture. Another option is to use a mounting block. These blocks are designed to be installed behind the siding and provide a solid mounting surface for the fixture. They are typically made of wood or plastic and can be cut to fit the shape of the siding. When using a mounting block, it is important to ensure that it is properly sealed to the siding. This can be done by applying a bead of caulk around the perimeter of the block where it meets the siding. It is also important to use screws that are the correct length and diameter to attach the fixture to the block. In some cases, it may be possible to mount the fixture directly to a stud behind the siding. This is the most secure way to support the fixture, but it may not be possible in all situations. If the stud is not located in the correct position, it may be necessary to install a blocking between the studs to provide a mounting surface for the fixture. When mounting the fixture to a stud, it is important to use screws that are long enough to penetrate the stud and provide a secure hold. It is also important to ensure that the fixture is properly sealed to the siding to prevent water penetration. Regardless of the method used to support the outdoor fixture, it is important to ensure that the electrical connections are properly protected from the elements. This can be done by using a weatherproof box and a weatherproof cover. The box should be large enough to accommodate all of the wiring and should be made of a durable, weather-resistant material. The cover should fit tightly over the box and should be designed to prevent water from entering. When making the electrical connections, it is important to use wire connectors that are rated for outdoor use. These connectors are designed to prevent moisture from entering the connections and causing corrosion. It is also important to wrap the connections with electrical tape to provide an additional layer of protection. Finally, it is important to test the installation to ensure that it is working properly. This can be done by turning on the fixture and checking to see if it is properly illuminated. It is also important to check for any signs of water penetration. If there is any water leaking into the box, it is important to correct the problem immediately to prevent electrical shock. Ultimately, the best practice is to use J-blocks. They offer superior weather protection, a solid mounting surface, and are specifically designed for outdoor electrical fixture installations. If J-blocks are not feasible, explore the alternative methods with careful attention to weather sealing and structural support. And remember, when in doubt, consult a qualified electrician to ensure a safe and code-compliant installation. The National Electrical Code, or NEC, provides guidelines for the proper installation of electrical equipment, including outdoor fixtures. Adhering to these guidelines is crucial for ensuring the safety and longevity of the electrical system. Several articles within the NEC are particularly relevant to outdoor fixture installations. NEC Section 314.15 covers the requirements for boxes in damp or wet locations. This section mandates that boxes installed in these locations must be listed for the environment and constructed to prevent moisture from entering. This typically means using weatherproof boxes made of non-corrosive materials. NEC Section 406.9 outlines the requirements for receptacles in damp or wet locations. This section requires that receptacles installed outdoors be protected by a weatherproof enclosure when in use. This can be achieved by using a bubble cover or a similar device that shields the receptacle from rain and snow. NEC Section 410.10 addresses the support of luminaires, which includes outdoor lighting fixtures. This section requires that luminaires be securely supported and installed in a manner that prevents them from falling or becoming damaged. This often involves using appropriate mounting hardware and ensuring that the fixture is properly attached to the building structure. NEC Section 110.3 provides general requirements for the examination, identification, installation, and use of electrical equipment. This section emphasizes the importance of using equipment that is listed or labeled for the intended purpose and installing it according to the manufacturer's instructions. In addition to these specific sections, other articles within the NEC may also be relevant to outdoor fixture installations depending on the specific circumstances. For example, NEC Section 250 covers grounding and bonding requirements, which are essential for ensuring the safety of the electrical system. NEC Section 300 addresses wiring methods, which dictate how conductors should be installed and protected. When installing outdoor fixtures, it is important to consult the NEC and any applicable local codes to ensure that the installation complies with all relevant requirements. This will help to ensure the safety and longevity of the electrical system and prevent potential hazards. Local codes may have additional requirements beyond the NEC, so it's always best to check with the local building department or a qualified electrician to ensure compliance. Examples of common code violations related to outdoor electrical fixtures include using non-weatherproof boxes in damp or wet locations, failing to provide weatherproof protection for receptacles, improperly supporting luminaires, and using equipment that is not listed or labeled for the intended purpose. These violations can lead to a variety of problems, including electrical shock, fire hazards, and premature equipment failure. To avoid these problems, it is essential to follow the NEC and any applicable local codes when installing outdoor fixtures. It is also important to use qualified electricians who are familiar with these requirements. In general, it's always a good idea to consult with a qualified electrician before undertaking any electrical work, especially outdoors. They can help to ensure that the installation is done safely and correctly. Remember, electricity can be dangerous, and it's always better to be safe than sorry. The importance of using the correct type of wiring for outdoor electrical installations cannot be overstated. Outdoor wiring is exposed to a variety of environmental factors, including moisture, sunlight, temperature changes, and physical damage. Using the wrong type of wiring can lead to a variety of problems, including electrical shock, fire hazards, and premature equipment failure. Several types of wiring are commonly used for outdoor electrical installations, each with its own advantages and disadvantages. One of the most common types of outdoor wiring is UF cable, which stands for underground feeder cable. UF cable is designed for direct burial in the ground and is resistant to moisture, sunlight, and physical damage. It typically consists of 2 or 3 insulated conductors surrounded by a grey outer jacket. Another type of outdoor wiring is THHN/THWN cable, which stands for thermoplastic high heat resistant nylon coated / thermoplastic heat and water resistant nylon coated cable. THHN/THWN cable is commonly used in conduit for outdoor installations. It is resistant to moisture and heat, but it is not designed for direct burial. A third type of outdoor wiring is use cable, which stands for underground service entrance cable. Use cable is designed for underground service entrances and is resistant to moisture, sunlight, and physical damage. It typically consists of 2 or 3 insulated conductors surrounded by a black outer jacket. When selecting wiring for an outdoor electrical installation, it is important to consider the specific environmental conditions and the intended use of the wiring. For example, if the wiring will be buried directly in the ground, UF cable or use cable should be used. If the wiring will be installed in conduit, THHN/THWN cable can be used. It is also important to consider the ampacity of the wiring, which is the maximum amount of current that the wiring can safely carry. The ampacity of the wiring should be sufficient to handle the load of the electrical circuit. The NEC provides guidelines for determining the ampacity of wiring based on the type of wiring, the size of the conductors, and the environmental conditions. In addition to selecting the correct type of wiring, it is also important to install the wiring properly. Outdoor wiring should be installed in accordance with the NEC and any applicable local codes. It should be properly supported and protected from physical damage. The connections should be made in weatherproof boxes and should be properly insulated. Finally, it is important to test the installation to ensure that it is working properly. This can be done by using a multimeter to check the voltage and current in the circuit. It is also important to check for any signs of damage or deterioration of the wiring. If there is any damage, the wiring should be replaced immediately. If you are unsure about any aspect of outdoor wiring installation, it is always best to consult with a qualified electrician. They can help you to select the correct type of wiring, install it properly, and ensure that the installation complies with all applicable codes. Remember, electricity can be dangerous, and it's always better to be safe than sorry. Understanding how to properly seal and weatherproof electrical connections for outdoor use is essential for ensuring safety and preventing damage. Outdoor electrical connections are exposed to a variety of harsh environmental conditions, including moisture, sunlight, temperature changes, and physical stress. If these connections are not properly sealed and weatherproofed, they can corrode, short-circuit, or even cause a fire. There are several methods for sealing and weatherproofing outdoor electrical connections, each with its own advantages and disadvantages. One common method is to use weatherproof boxes and fittings. Weatherproof boxes are designed to protect electrical connections from moisture and other environmental factors. They are typically made of durable, non-corrosive materials such as plastic or metal. Weatherproof fittings are used to connect conduit and other wiring to weatherproof boxes. They are also designed to protect electrical connections from moisture and other environmental factors. Another method for sealing and weatherproofing outdoor electrical connections is to use liquid-tight conduit. Liquid-tight conduit is a flexible type of conduit that is designed to prevent moisture from entering electrical raceways. It is typically made of plastic or metal and is available in a variety of sizes and lengths. A third method for sealing and weatherproofing outdoor electrical connections is to use heat shrink tubing. Heat shrink tubing is a type of plastic tubing that shrinks when heated. It is commonly used to insulate and protect electrical connections from moisture and other environmental factors. When using heat shrink tubing, it is important to select the correct size and type of tubing for the application. The tubing should be large enough to fit over the connection, but not so large that it does not shrink properly. The tubing should also be rated for outdoor use and should be resistant to sunlight and other environmental factors. A fourth method for sealing and weatherproofing outdoor electrical connections is to use electrical sealant. Electrical sealant is a type of caulk or adhesive that is designed to seal electrical connections from moisture and other environmental factors. It is typically made of silicone or polyurethane and is available in a variety of colors and formulations. When using electrical sealant, it is important to clean the surfaces to be sealed and to apply the sealant in a thin, even layer. This sealant should be allowed to dry completely before the connection is energized. In addition to these methods, there are also a number of specialized products available for sealing and weatherproofing outdoor electrical connections. These products include weatherproof connectors, cable glands, and sealing compounds. When selecting a method for sealing and weatherproofing outdoor electrical connections, it is important to consider the specific environmental conditions and the type of connection being sealed. For example, connections that are exposed to direct sunlight or extreme temperatures may require more robust sealing methods. It is also important to follow the manufacturer's instructions when using any sealing or weatherproofing products. A proper installation can compromise the effectiveness of the seal and may even damage the electrical connection. Finally, it is important to inspect outdoor electrical connections regularly to ensure that they are properly sealed and weatherproofed. Any signs of damage or deterioration should be addressed immediately. This may involve replacing damaged components, resealing connections, or even replacing entire sections of wiring. Remember, maintaining the integrity of outdoor electrical connections is crucial for safety and preventing damage. Proper sealing and weatherproofing can help to ensure that your electrical system operates reliably and safely for many years to come. The importance of grounding outdoor electrical fixtures cannot be overstated, as it is a critical safety measure. Grounding provides a low resistance path for electrical current to flow back to the source in the event of a fault. This helps to protect people from electrical shock and to prevent damage to equipment. When an electrical fault occurs, such as a short circuit, the current will flow through the grounding system back to the source. This causes the circuit breaker or fuse to trip, which cuts off the power to the circuit and prevents a dangerous electrical shock. Without proper grounding, the current could flow through a person's body to ground, causing serious injury or even death. Grounding also helps to protect equipment from damage. When a surge of electricity occurs, such as during a lightning strike, the grounding system provides a path for the surge to flow back to the source without damaging sensitive electronic components. There are several methods for grounding outdoor electrical fixtures. One common method is to connect the fixture to a grounding electrode, such as a ground rod. A ground rod is a metal rod that is driven into the ground and connected to the electrical system. The ground rod provides a low resistance path for electrical current to flow back to the source. Another method for grounding outdoor electrical fixtures is to connect the fixture to a grounding conductor, such as a bare copper wire. The grounding conductor is connected to the electrical system and runs along with the circuit conductors. The grounding conductor provides a low resistance path for electrical current to flow back to the source. A third method for grounding outdoor electrical fixtures is to use a self-grounding fixture. A self-grounding fixture is designed to make a direct electrical connection to the metal enclosure of the electrical box. This eliminates the need for a separate grounding conductor. When grounding outdoor electrical fixtures, it is important to follow the NEC and any applicable local codes. The NEC provides specific requirements for the size and type of grounding conductors, as well as the installation of grounding electrodes. It is also important to ensure that all connections are tight and corrosion-free. Loose or corroded connections can increase the resistance of the grounding system and reduce its effectiveness. Regular inspection and maintenance of the grounding system is essential to ensure its continued effectiveness. Any signs of damage or deterioration should be addressed immediately. This may involve tightening connections, replacing corroded components, or even replacing entire sections of the grounding system. Remember, proper grounding is a critical safety measure that can help to protect people from electrical shock and to prevent damage to equipment. If you are unsure about any aspect of grounding outdoor electrical fixtures, it is always best to consult with a qualified electrician. They can help you to ensure that the grounding system is installed correctly and that it complies with all applicable codes.